So sometimes your cells will eventually grow confluent or in colonies. So in our part 2, we're going to show you another way to do it with confluency. So let's get started. So we're going to create, let me slow it down. We're slowed down. So we're going to load a plate, and this example we're going to do a 96 well plate. It's the Griner 655090. It's a black wall plate. We'll give our plate an ID name, so this is kind of like a file name that you can refer back to and keep loading back up. And then we're going to load the plate. So this will move over, once the stage opens up, you put this plate on and then click OK. We'll move over to the Scan tab. And from this drop-down menu of the applications, there's a long list of options for you to select. We're going to look in the Applications Analysis Application section for Target 1 plus Mask. It's about 2/3 the way down from this menu. And you'll see that there's quite a few different expression analysis. We want the very last one, which is Target 1 plus Mask. This is a 2-channel application. So in this application, we're going to set up the 2 different channels. The Target 1 is going to be for green fluorescence, which identifies our GFP cells. And then channel 2 is our mask channel, which will be our bright field image detecting all of the cells. So I'd like to set up the mask channel first. So we'll select the mask. And the question I get in the field is, what is a mask? Well, mask is going to be the cell outline that helps identifying cell in the image. And that area defined will help us pick up the area of interest for where we want to look for fluorescence in the green image. So we'll just change the illumination for this bright field mask channel. Illumination down bright field. And then we'll want to set up the focus. So at the very bottom of the screen, well, first, let's move the stage over to C4, where we have a good sample. So select a well on the plate move, and the stage will move over to C4. And then we'll want to turn on the live camera. So the default exposure is about 10,000. That's a pretty bright exposure, so we want to actually have a pixel intensity background of 120 to 150. You can see the values displayed at the bottom of the screen. So at this point you can click Auto Calc, and it allows the system to try and figure out what the best illumination exposure should be for bright field to give you that 120 to 150. So this is just a one-time thing. You can see that now the pixel intensity of the background is about 125. So this exposure value will be used for all of the wells. So at this point, we'll turn off the camera and click focus. Oh, no, we'll just go focus that up. And then the dialog box opens up, and we'll just click Register Auto, because we're going to use the hardware autofocus mechanism. The system will find the best bright focus contrast. It's kind of like you're on the microscope and you're dialing up and down to try and find the right, best focus in the screen or the image. That's what the system is doing, and then it'll apply hardware focus beams at the bottom of the plate when it's finished. And those beams will be now used for when you want to move to another well. It'll use the beams to register the focus position instead of having to move up and down in Z. It just is a much faster mechanism. You can close the dialog box by clicking Focus Setup. And now you can use your mouse to pan and scroll the image to see that your cells are in focus. So similarly to the ceilometer, the ideal focus is to have a bright center with a dark outer edge and a flat background. So that's how the bright field algorithm to identify the cells works. So you want to have the majority of your cells in that bright fuzzy focus. So I like to just defocus a little bit, so just using the down arrow. You're still in the live camera mode, so you can see as you click down on the Z, this image will actually get a little bit blurrier, but it's better for the algorithm to pick up the cells that'll have a more bright center, less detail from the nuclei that might show up in your cells. So on average, I'm probably between -5 and -10. Some really flat cells, you might want to go -15. It really is kind of a range you have to see for your cell type. So once you're happy with that view of how the focus is, then you can see that this current focus offset value is displaying down there how many microns are different or delta from the hardware autofocus registration. So currently we're at -6. So what we'll do is click Set Offset, and now that is telling the system, so you can see the numbers now displayed up here, that when the hardware focus mechanism moves and registers, it will also move -6 before it takes the bright field image. All right, so we've set up the bright field mask channel. Now we'll switch over to the other channel, the target one, and set up the parameters for this channel. So the first thing we'll do is change the illumination to green. And that's also the filter sets, the wavelengths. So if you ever need to know what dyes work with what are filter sets, they're labeled right next to the name green. And then you just click on the live camera. And so you can see some GFP cells there. They're dim and a little out of focus. So we're going to fix that next. So you can see that they're out of focus. We'll fix that first by clicking Find Focus. And this is again like you moving the microscope up and down in Z to try and find the right focus, but it's engaging the system, the computer trying to do it. And it works pretty well. I could probably use that more times than me trying to find it myself. Okay, so it's found the right focus. You can move around and make sure that it looks good. I'm happy with it. So at this point, we're going to click Set Offset because this 28 micron positive from the hardware focus is where we want to capture the image. And we'll let the system do that 20 micron positive from hardware focus when an image captures for green. Now the next thing we'll do is set up the illumination. So it's a bit dim. So 10,000 is a default value. We'll just bump it up to 50,000. And the ideal pixel intensity, for fluorescence, you just want to have a majority of your objects oversaturated. The camera maximum is 255. So you want to be something in 200 range, but make sure that you kind of have, the dim ones are visible, but the majority of them are not oversaturated. Next, we'll select the wells we want to image. Just click the selection button, and the space between A1 will highlight the whole map. So now that they're color-coded red, we can or yellow, we can click Start Scan. All right, so we've moved over to the Analyze tab, and the system is beginning to acquire the images for both green and bright field. Let's customize our application. Instead of saying target 1 and mask, we can just click on this little icon and change the labels that are being displayed. So we'll change the channel names, which are our images, and the features, which are the graphic overlay identification objects that we're going to be looking for. And we'll label it green and bright field. And then the class is going to be the subclasses that we're going to define in the gating tab. So GFP negative, GFP positive, and then click OK. So we get up to 4, but for today we're only going to report 2, besides the total. Okay, so now you can see the image display is saying green and bright field for the image display and the graphic overlay as well. All right, so now you can see the plate map has green wells on it. Those are all saved images on the computer. So you can just click on a well, and the image will appear in the displayed area. And this is both images are appearing on top of each other, and you can turn them on and off so you can see them individually or together. And what I like to do at this point is check for illumination and focus to make sure everything's good. It looks really good. You can pan and scroll the image with your mouse. And then for this application, Target 1 Plus Mask, we really only need to set up the bright field graphic overlay. So I also like to look at the edge of the well to see how the focus and illumination is, and we can also show you what the well mask is doing. So let's click on the well mask and then turn or checkbox the well mask. So this is an outline defined from the manufacturer's specifications of the plate. And an orange line appears. So this is basically, you know, the system will only analyze objects inside the well mask and ignore anything beyond it. It's a little big, so just shrinking it a little bit will shrink it up to the edge of the well mask, or the well itself. So now turning on the bright field graphic overlay, it highlights the cells in green. So these are the parameters that we're going to want to adjust a little bit on the left-hand side. I usually work in a top to bottom method here, so we already did the well mask. The next thing I want to do is identification. So we'll change the algorithm to from fluorescence to bright field because we're looking for bright field images or cells. And the algorithm, as I said before, is looking for a white cell with a dark edge and a gray background pixel intensity. Okay, so we've done a pretty good job with the default settings. We loaded these settings up originally because it's pretty good middle ground for most objects that you're going to be looking for. And it's okay if you over-identify objects. We're going to actually remove some of these smaller things in the gating tab. So I like to pick up as much as I can to make sure that the things that I want picked up are being picked up, and I'll filter out stuff later in gating. So it's doing a good job, so I don't have to change them too much. If I had to adjust something, it might be the intensity threshold or the size. But at this point, we'll just move over to the gating tab by clicking the gate tab. And we'll select one of the green wells. Now the images are still being acquired, and we're still setting up the parameters at the same time. So now you can see this whole well is stitched together. It's not just one image anymore. So you can raise this graphic area by clicking the up arrow, and now you can see the whole screen is displaying the image. You can turn on and off the images. So this is zoomed out. Now we're zooming in. And I would say the focus looks good across the whole well. The illumination looks good for the fluorescence. You can turn off and on the graphic overlay. Looks pretty good. So we have some green cells with non-green cells. Okay, so we'll lower that graphic area by clicking the down arrow, and we'll turn on the graphic overlay. And the first graph we're going to create, we'll use the green plus sign. You can see that the blue outline is the objects that we identified in the Analyze tab. So we'll want to get rid of some of the small objects. So we're going to make a plot from a histogram plot. And the first parameter is going to be area. So we want to get rid of those small objects. We need to plot all of the objects according to their size. And now you can see that we have two peaks, the very small cells or objects, and then the very big objects, which are our cells. So we'll just use this min-max range gate to create a separation or a gate to identify what we want to be called a cell. Its color is currently red, and so now anything inside that min-max range gate is also color-coded red on the image. And so you can see that this is working pretty well. We're going to checkbox on the left the total. So rather than all the objects we identified in the Analyze tab, now only objects inside this min-max range gate will be called our total. It's our denominator for our percentage. So now we'll make another plot by clicking the green plus sign, and the source population will be this new population 1 total that we just defined. You can see all is coming from the previous source. And then the plot type will be a histogram. And the plot parameter is going to the mean intensity of green. There it is. So all the objects in the red are going to be plotted according to their green mean pixel intensity. And we've removed all the other ones outside of that red. And this time we'll use the splitter gate and then click in the peak or the valley area between the two peaks. Okay, and so it's basically color-coded mint green and aqua green. They're kind of close in color, so let's change it to something a little bit more contrast. So we'll make this population 3 a dark green, because that's going to be our GFP positive. And then the population 2, we'll change it to an orange. It's a good contrast color. Okay, so now on the graph and on the image, you can see that the colors have been updated. So the GFP negative is orange, and it's the left peak. And you can see the cells are properly identified on the image. The only thing we have to do now is check the box GFP negative. This is telling the system we want to report on this population in the graph, and we're going to call it GFP negative. This is our green color on the right side of the histogram. These are our GFP positive cells, and they're looking pretty good. It looks like we did a good job on our selection of the splitter location. And we'll just checkbox this because we want to report this as the GFP positive population. If you want to take a preview view of the results, just click on this results, and a little box will open up on the right-hand side and give you an example of what this well is going to look like. So it's about 54% negative, 56% positive. You can see you get counts. You also get the total count, which is coming from our red population, as well as intensities, mean and integrated. It's a lot of information. So at this point, I like to click on some control wells to make sure that I have my gate set up in the proper location. So it's a good idea to have on your plate control wells that you know are completely negative and other ones that are completely positive. It's just a good technique to get your splitters in the right location. So here's our GFP negative population. And we're just clicking on some wells in the plate map on the right-hand side. This image updates, the graphic overlay, and the histogram all update. That looks pretty good. So if you're happy with your location of your splitters, then all you have to do is select the wells you want to analyze like this, and you can see that we're still acquiring some images. We'll just go ahead and select all the wells we want to analyze. So we're now going to be acquiring and analyzing at the same time. And then just click Start Analysis. Now we've moved over to the Results tab, and you can see the green channel thumbnail images are being displayed. That's how we can change it if you wanted to on the left-hand side. If you wanted to display the right field one, you just toggle that. And then also the data being displayed currently is the percent GFP negative. So you can, I like to use the heat map as a good way to kind of identify the high, medium, and low. We're going to change over to the GFP positive and turn on the heat map. And you'll see that the increasing GFP is going from left to right, and the data displayed is also showing that. Okay. So now we'll want to double click on a well and open up the high resolution image, and we'll have both images overlaid on top of each other. You can at this point grab this image and scroll it around or pan it around and scroll. You can turn on and off the images, and then the graphic overlay, currently the class, which is referring to the gate tab. So then our class is referring to the gate tab and the classification subpopulations that we want to report. So now you can see the GFP negative and the GFP positive displayed on the left-hand panel are percentages, counts, and pixel intensities. And it looks like it's doing a pretty good job with the graphical relays identifying the right populations. And now we'll just click on a control well and see that we have a negative population, and the GFP negative overlay is properly identifying the objects. It looks pretty good. And there's no negative or no positive cells. That's pretty good. And then we'll click on a high percentage GFP. There's a medium percentage. Okay, so let's go back to, clicking back to scan brings you back to the plate view, and we'll just click export well level data. This is allowing you to export the data into a CSV format, so this is what you would put into Excel to make your graphs. And then we'll just save it to the desktop. Okay, so then we'll also want to show you how to export the images. So if you want to just look at one image, you can right-click on this individual image and then click Export Scanned Area Images. This will be the raw image, and you can do it in 3 different formats, and it will be stitched the whole well. And then we'll save it to the desktop. And at this point, they're not merged. They're individual Brightfield and individual GFP images. Then if you click on a single well and you're in the displayed area, and you can see that you're zoomed in, you've got the 2 images overlaid and they're colored with the green. And this is something that you would want to capture in your report. You can turn on and off the graphic overlay if you want, and then just click this displayed save icon, and it'll just save the image that's in the display area as is at this zoomed in level. Again, it can be in any of the 3 formats. And then it's okay. All right, so another way you can also export this raw image is this export image icon, and it is again the stitched raw whole image, black and white. Let's click the X to end this session and go back to the Start tab. And the next thing I want to show you is how you can analyze super confluent or difficult to identify individual cells using another application of confluence ratio. So this example came from the field. A customer of ours had some cells that were growing into colonies, and she wanted to report the percent GFP. So it is in a 6-well plate, and there's 2 rows. Row B is going to have the control wells containing the GFP cells, and the row A has the treated wells that have more GFP. And then, like I said, the cells grew into colonies instead of individual cells, and they had low GFP percentages. So there was also a background fluorescence, and so we used the confluence ratio to get the percent GFP. That's what we want to show you next. We're now in the Analyze tab. And you can see it's a 2-channel application called confluence ratio, and the order of the channels is the same as what we did before. So we have confluence 1 with our green fluorescent images, and the confluence 2 is our bright field illumination. So if you acquired it in the same format that we did previously, you can analyze it in this application. Now you can see the cells have grown into colonies, really tight, hard to see individual cells. So it's easier for us to use the texture algorithm to detect these colonies versus the individual cells. So this is a texture-based. Basically, it's looking at changes in the pixel intensity. So lowering the intensity threshold will pick up more areas in the image, and as you increase the value of the intensity threshold, it will pick up less areas, more of high pixel changes. So that's kind of how the severity looks from 5 to 25. So let's see, 15 might be a good value. So clicking Analyze will update the values, update the graphic overlay after you've checked your number. All right, 10 looks pretty good, I think. Yeah, that looks good. So now let's observe the confluence 1, which is our fluorescent green image. So you can see that the GFP resides inside these cell colonies. And so then we'll just want to identify the graphic overlay of the green cells using the texture algorithm again. So this purple outline is looking at the green cells. We'll change the channel identification to confluence 1. And let's see. Yeah, 10 may be good. And if you're not wanting to click Analyze every time, you can also use this Auto Analyze checkbox. And then every time you change a parameter in this column, it'll automatically update it once you hit Enter. Okay, that looks good. 15. Yeah, we'll pick up some of those lighter green cells. So again, remember that the GFP is being identified with a purple outline, and the bright field is in the green, and the purple is sitting inside the green. All right. So now we're in the Results tab. It's been analyzed, and we're going to look at the results. So here we have the bright field image, confluence 2, and the green cells in confluence 1. And the data displayed on the left, we'll first look at the confluence 2, which is the green outline. And so on the left-hand column, you see confluence 2 percentage is about 50%. So that's the area coverage of the whole well. And then the confluence 1 is the purple outline, picking up the green cells. And the confluence of that area is about 7.84%. And so using those two numbers, we can calculate the confluency ratio. So basically, we're getting about 16% confluency transfection efficiency for this particular well. Okay, so let's look at, this was row A, which had a lot of a lot of GFP, and B is the control well, which had less. So you can see that the bright field area coverage is about 58%. And then the green fluorescence coverage is about 2%. And so that gives us a ratio of about 4% transfection efficiency. So this is a really good application because if you need a long time for your cells to grow, they might be confluent in the bright field channel, but you can still get some kind of evaluation of your transfection efficiency without adding any dyes. So this is something you might want to use, you know, day 2, day 3, day 4. Oh yeah, so sometimes we've had some issues. We wanted to talk to you guys about some options to help you out with. So I found that some plates actually autofluoresce, so it's ideal if you can use a black well plate. It's not necessary, but it's ideal. Some media components can actually autofluoresce, so you might want to identify what is the autofluorescent reagent and then determine if it's really necessary to be in your media. Cells can also produce excess fluorescent proteins excreting into the media, so it's nice to be able to wash your cells with PBS or fresh media before you image it, if that's the case. And then sometimes drug treatments can actually autofluoresce in high concentration, so it's not ideal, but if you can add a reagent that reduces the autofluorescence, then that might be the option for you. Okay, so at this point, this concludes the training session, and we want to open up the forum for anybody to ask some questions.
Thank you very much, Sarah. That was a great presentation. So as I mentioned, we do have some time now. If anybody has any questions about the material that we just covered, please feel free to type it into the questions bar. We'd be happy to answer any questions you may have. While we give people some time to put their questions into text, I'll also advise that with these Celigo training webinar series, a lot of what we present is driven based on questions we get from the field. So if you are currently using Celigo and you have a topic or an essay or an application that you would like to see presented or you think would be a good webinar, please feel free to submit that to us. You can just reach out to us at support@nexalum.com with your topic idea for a webinar. And you never know, maybe in a month or two you'll see our webinar on your topic. So you have it right there on the screen, support@nexalum.com. And I did mention this at the beginning, but this session has been recorded, so we will be able to get